Hey guys, the Network Berg here. Hope you've been doing well. I am super excited to be making this video because this is going to be touching something that I love working with, namely VPNs. Now we will be looking at how to create our own VPN server in the cloud that you can use for many different things. You can use it to access resources on the cloud. You can just use it for VPN tunneling as a concentrator between sites. So you can almost set up like a hub and spoke network between all of your remote ends. Or maybe you just want a way to access streaming content similar to using something like Surfshark or NordVPN or whatever without having to pay those guys for those services. So if you host your own cloud-based VPN server, depending on where the server is located in the cloud, you will be seen as originating from that source. So you could be seen as coming from America, and then you can see the American Netflix shows. Same for Britain or Japan. So it's all up to you. So let's actually jump into the video and configure our own VPN server in the cloud. So I think a great place for us to start would be to decide what cloud provider we want to use. Now you can go for whichever hosting remote provider you choose. However, I've personally found that AWS is relatively good. They do offer some free tier services where you get certain amounts of hours that you can run the infrastructure for and a certain amount of bandwidth basically for free. So it's great for just labbing and testing things out with. And I think the actual cost to just keep the stuff running, if you do exceed that hour costs or the bandwidth cost, it's quite minimal. So for a normal person, it's definitely in my book the better option between cloud providers. But if you find another provider that can do stuff like CHR and it's cheaper for you, then you can definitely go for that. But I'm focusing on AWS. Reason being, it's very quick to get started, and it's also so easy to just bring up an instance or a virtual machine basically that will be running a cloud hosted router that we will be using as our VPN server. So what I'm going to do is just go onto Amazon Web Services. Now I've already got an account and I can already sign in. But if you don't have an account, then you can just create a new account, and it's really a straightforward process of just saying what the root user is going to be and who's going to access what, and off you go. Now you can start managing stuff. So let's sign into the console quickly. And pardon if, all right, it's already just in, so that's great. So initially, if you get in, you might be prompted into this EC2 screen, and EC2, you can just think of this as kind of like where everything is set up for your virtual networks when it comes to AWS. Now, I have different instances. You have instances that are running, which is basically a virtual machine that is already up and running and it's working, or you can just clear that or go into your dashboard. And if you go into just instances, you can see all your instances. So even instances that aren't currently running. Now, what I'm going to do is I'm actually just going to create a new instance, create a new virtual machine, so to speak, so that we can connect to that. Now, the region is obviously where you're setting everything up now. So currently I'm in North Virginia, but if I click down here, you can go to different regions to configure your virtual machines. Now, if you're going to be using this as a concentrator for almost like side-to-side VPNs and such, then I definitely recommend going to your closest, let's say cloud almost. But if you are going to be using this for stuff like, you know, streaming services and whatever, then find the region that you'd specifically like to access content for. And I'm just going to leave it on America for now because I've been doing some tests just to see the performance between different VPNs. But I felt so strongly about this VPN or this video that I just wanted to get it out now. So next step is let's actually create a new virtual machine. So what we can say is we want to launch a new instance, so launch instance. And here you can give the instance a name. So I could make this like my MikroTik VPN server. And that's just a tag. It doesn't really do anything. Think of this just as a name for you to understand what that is. And now we have this nice application and OS images. So Amazon Machine Image, an AMI. Now from here, we can actually find a specific machine image. And I want to stress, this doesn't just have to be MikroTik. If you feel very comfortable with running something like a Linux server and installing VPN stuff on there so that you can use that as a VPN server, by all means, go for it. Just pointing that out now, but I'm going to keep this for MikroTik. So I'm just going to search for MikroTik. I could search MikroTik or CHR, and it's going to bring me to this little marketplace type of thing. And then from here, I can see there is a cloud hosted router. So this is perfect for me because I can just go in there and it will give me some information about the cloud hosted router. And here you can see like what the cost is. Let's see the additional pricing as well. But here it will give you a rough breakdown of what it costs to actually bring up this instance, this virtual machine. And for this EC2 per hour, it's like 0.012 cents, which I think works out roughly to about $8 to $9 a month if you run it consistently without turning it off. But that is just the infrastructure side. That doesn't include, I think, the bandwidth. But let's just continue. So, but if you are using the free tier, by the way, then you can basically run this, I think, for like 700 hours or something. But I'm not too there, 750 hours a month, but I'm not going to go too far into the free tier stuff. This isn't an AWS guide or anything. I'm also not an AWS advocate or whatever. I just find it interesting or easy to set the stuff up on here. So what we can do is we can also look at the usage, and we'll just basically tell you how it's going to allow you to set up the MikroTik initially. And by default, it's just going to allow SSH, and then you should use the RSA key. It's basically just a certificate that you can download onto your terminal client, and then you can quickly and easily access that MikroTik. So I'm going to just bring this up. I'm just going to continue with this, and we should actually see here some of the details. Verified provider, all this good stuff. Number of instances, it's a single instance that we will be running, so I'm happy with this. And here we can also just see some of the specs. It does have 1 virtual CPU and 1 gig of memory, and it is free tier eligible, so I'm very happy with this. So let's just do a launch instance. Key pair. Sorry, I forgot about this. So this is kind of where you are going to be setting up that certificate that I was just speaking of. Now, I've already got a key here, or I can create a new key pair if I want, but let me just use my current key that I already have so I don't have to download it again. Actually, let's create a new key. Let's do that. Let's create a new key pair, and I'll make the name MikroTik 2, and then I'll just create this key pair. And I think I actually created that incorrectly. Sorry. I want to use this with PuTTY. So let's MikroTik 2. 23. So I want this for PPK so I can use it with PuTTY. I don't use OpenSSH, even though it's fine to use that as well. Let's just create this new key pair. It has downloaded onto my machine, and at the moment it allows SSH from anywhere. Now you can also tweak the security groups as you want. You can select the existing security group or create a security group. What this boils down to is basically Amazon or AWS's firewall rules when it comes to this machine, so how you can access it on its public IP. So if you want to allow more than just SSH, you can also enable additional ports or create a existing group just to allow stuff like Winbox in the future if you want to, but let's just leave it as it is. We're just going to SSH onto the device, and I think we'll do some of the setup from the terminal. And now we can configure our storage space. I'm not going to add anything else. I'm basically leaving everything standard. The only thing I've added was this key pair, as you guys saw. So I'm just going to launch my instance, and then when this instance actually launches, it's going to bring a virtual machine up in that dashboard that I can use to connect to and configure, and it will work exactly like a normal MikroTik device. The only issue is it is going to be running on a free license, so it will be limited to 1 megabit per second. So what I do recommend you do is, if you are going to host a CHR on AWS, that you either use one of your free licenses that you get when you pass a MikroTik certificate, which is what I did, so that you get that P1 perpetual license, or you will have to buy a license, which is going to cost around 45 USD if I'm not mistaken. So it's completely up to you, but that is still really cheap if you think about it, if you're going to be having your own VPN server, so that you don't need to rely on stuff like Nord or Mulvad or whoever, because then you are the boss of the VPN, which is crazy. All right, so this thing has actually done its business. It has actually launched. So let me just go back into my dashboard. I misclicked there for a bit, sorry. So I'll just go into the dashboard, and there I can see 2 instances are running. Now I should see that my MikroTik, this is the new one that I created. There's the instance ID. It's telling me it is running. It's doing some status checks and such. But here I can see what the public IPv4 address is of the device, so I can actually get onto it if I want to. So let's actually do that. So what I'm going to do is I'm just going to grab this public IP, and I'm going to head into PuTTY. I'm going to put the host name in here. I'm going to connect over port 22 because it was SSH. And I'm just going to add that certificate quickly. So I'm going to go into this auth and just add this MikroTik 23 PPK. I'll hit open, and this should actually prompt me to log in now. So there we go. It's just doing its thing with the certificate. Let me just accept. and log in as admin. And since this is now authenticating via the certificate, if I hit enter, it's just going to log in. Done. It's using that key that we created. So we can see the licensed software if we want, but I'm not too interested with that. I'd recommend you go through that at your own pace, but here we are. We are now on a CHR hosted in AWS that you can use for many different things. But my thing that I want to do is use this as a VPN like server. So you can decide what VPN you want to use. I'm going to make a video after this just highlighting some of the different VPN options, but I do think Wireguard is exceptionally good for VPN connectivity, so I'll be setting this up as a Wireguard server. So let's quickly run through the Wireguard server setup. One very important note, before we can actually use Wireguard, we need to run RouterOS version 7 because the package only exists for version 7. Now, CHR does support it, great. However, we can see that when we've logged in that this is running version 6.44.3. Now, this is not going to allow us to configure Wireguard. So to get Wireguard on this, what we can do is update the system or RouterOS to version 7. And this is as quick and easy as going system, package, update, and then we can do a set command and we can set the channel to testing, should be fine. And then if I do a system package update, check for updates, and I hit enter, we should see version 7.6, which is the latest stable build of RouterOS version 7. So we are going to just go back up. We're going to do a system package update install. Now this is going to install the new package on this CHR. It is going to take a little bit of time since we are limited to 1 meg. So while that 1 meg limitation is happening, let's actually go on to MikroTik's site. So I'm just going to Google quickly MikroTik CHR license, because this is going to be super important. Now I'm just going to go into the MikroTik wiki. I will put a link in this for the description or in a pinned comment. But what this comes down to is you're going to have to run some commands on the CHR to move it from a free license to P1, which is the $45, so that you can actually use 1 gigabit interfaces on it. So you get that 1 gigabit speed. If you just want 1 megabit, then you can leave it on free. If it's just for testing or whatever. But in this day and age, I think 1 megabit is going to feel extremely slow, especially with certain sites and videos and such. So I can definitely recommend at least upgrading this to 1 gigabit. You can go for the P10 license, which is 10 gigabit ports for just $95, which isn't bad at all. But that is obviously going to push up your cost with the AWS side of things as well, because you're going to have to change, the resources. You're going to have to give it more bigger interfaces, and it's just going to cost you a bit more if you're using this on AWS. So I think 1 gigabit is going to be what most of us is going to be using. But in essence, just going to tell you getting the license and what the path is. Basically, you're just going to renew your license. You put in your account details with the MikroTik portal, and then on the MikroTik portal, when you check your CHR keys, there will actually be a thing there, like an object that you can upgrade from here, which is very nice. It's such a straightforward process, but I think I just wanted to mention that before we continue. Now let's get back to our VM. It should be running again. So all I'm going to do is just restart my connection. So let's restart the session and log in as admin, password blank, and now it's asking me to set a new password, which is good because version 7 forces you to change passwords. So I'll make this TMB123, very straightforward. And presto, now we are on a version 7 CHR, so we can actually set up Wireguard. First thing I'd like to do is also just add a new admin user, because I feel like that's almost a normal thing to do with any MikroTik. I'm just going to create a new user, call it, name is going to be TMB_admin. And then my password, I'm just going to make this something for me. And the group will be full. So next step is actually going to allow the Winbox port as well. So we can administrate this MikroTik on its public IP via Winbox. Not something you typically want. You definitely want to restrict it to trusted hosts or allowed from addresses. But since this is just for the demonstration, I'm going to do it this way. So let's just do an IP service print. And we can see what the Winbox port is, 8291. So let's just allow that on AWS. Now, if I go back to my AWS instances, I can log into my instance ID for my MikroTik server. And if you go to the security, this is in essence the security rules for the AWS firewall for stuff that's being allowed to your instance, to your virtual machine. So let's tweak these rules a little bit. So I can go into this security group that was created or auto-generated when we created this instance. And I can, in essence, edit my inbound rules. So I can edit what happens to traffic that wants to go to my MikroTik. So at the moment, it only allows SSH. So let's add one rule, and we're going to come back here later to actually add the Wireguard listening port. But for now, let's add the Winbox port. So custom TCP, the port is going to be 8291, and I'm just going to put this as a 0000/0, so from anywhere. And I'm just going to say Winbox access as the optional comment. Let's save the rules. And then what I would like to do now is see if I can actually access this MikroTik on its public IP using Winbox. Now, I know this feels like there's a lot of stuff we're doing, and we are, but we're doing this properly. I wanted to show you guys the process end to end, or start to finish, so you don't feel like I'm skipping steps and stuff. So let's see, can I log in with TMB admin and then my password? And we're logging in. So perfect. So we are on the AWS MikroTik. And I've also got a Winbox session already open to a CHR that I've got running locally on my hypervisor, on my actual computer. And just to also go over the setup scenario quickly, I have a CHR on my hypervisor, and behind it I will have an Ubuntu VM just to run some tests with and see what the VPN feels like. So let's just go back. So let's start by configuring our Wireguard server, which is on the left hand side. So let me just maximize that. And you can start off just by clicking on Wireguard. Now this will bring you to the space where you can configure a Wireguard interface, which will in essence do stuff like set a name for an interface, set the MTU, and give you a private and public key. The public key is important because that's what you share with the people that you'd like to be able to connect to you. And the private key, you need to make sure you keep that private, because if that gets compromised, then people can in essence connect to your Wireguard and cause some havoc. But that should technically never happen. So let's click on plus. And what we're going to do is just give this a new name. So I will make this WG-server. My MTU will be 1420. That's the default. It is there for IPv6 as well. So that's actually quite nice, because you can actually use Wireguard on IPv6, connect to AWS, and then do some trickery with AWS or IPv6 there to get that IPv6 experience, which is quite nice. But I'll leave this for IPv4. I just wanted to point out that the MTU is 1420 by default. If your ISP has some MTU issues, you might have to tweak this a little bit to get a number that's going to feel stable for the tunnel. But for most people, 1420 is fine. The listening port is what's going to need to be open on a firewall. Now, CHRs by default don't have any firewall rules, but if you are using any other type of MikroTik, like a router board, or maybe it's a CHR that's already in production and you've added firewall rules, then you just need to make sure that you allow 13231 on your input chain for anybody that's going to be connecting to you. Now, if I click on apply, it will generate a private key and public key for me. So presto. So I can use this public key and actually share that with the client, which will be my MikroTik at home in South Africa, running on a VM to connect with. But before we continue, we're just going to add an IP address to this interface as well. So to do that, we go into our IP addresses, add a new IP address. We're going to make this 10.0.1.1/24. Going to bind that to my WG-server interface, and this you can really make any private IP that you want. This is just something I had in the top of my head. Now that we've added an IP to the server, we can actually in theory add a peer. But if I go to my peer tab and I click on the plus, I see what the interface is, which is just the only interface we have, so that's fine. But the public key, I don't know what that is. So I'm going to have to get that from my client, from my peer, from my other router. So let me log onto that router quickly. And to get that, let me just maximize the screen. We're going to follow the same process. Go into Wireguard, add a new interface, and this I'm going to call it WG-AWS-US1. MTU, keep it on 1420, listening port, keep in 13231. I'll just hit apply. Now I'm just going to copy this public key so long, but before I do anything else, I'm also just going to add an IP address to this Wireguard interface. Now this IP I'm going to make 10.0.1.2/24. I'm going to bind that to my Wireguard, interface and I'll hit apply. Now this side is done. So let's go back to the server and add that peer. So public key I can just paste in here. Endpoint I'll leave blank because I might not know what my endpoint address is or what the public IP is or what their ports are. Let's say they're a road warrior, they're connecting with a LTE device a lot and their public IP changes a lot, so I'm not going to be too worried what their details are, but my IP needs to they need to know what my details are so that they can initiate that connectivity the first time around. Allowed address, think of this as the stuff that you would like to get to and also the stuff that you're allowing to communicate through the tunnel. So what IPs live on the other end that you are allowing to get to anything on your router or to any other tunnels. Now I know that 10.0.1.2/32, important, /32 single host, single IP. I'm just allowing that WireGuard IP on my home MikroTik, my home CHR to connect. But if you were having any servers and you'd like to get to those servers as well as for site-to-site VPN, you can just hit this down arrow and add those server IPs or ranges in here and they'd be accessible as well. I'm not going to set any pre-shared key or persistent key apply. I just want to leave this as simple and easy as possible. So I'll just hit apply. And now that this has been done, let's configure the peer on my client. So I'll go into the server and quickly grab its public key. And then I'm going to go onto my client. And then from my client, I'll head into the peers, add a new peer. The interface will be this wg-aws-us1. Public key, paste it in. Endpoint will now be the IP address of the AWS instance. So let's quickly grab that, 54.198.202.70. I'm just going to copy paste. And then the port will be the WireGuard port. So that I know was 13231, 13231. And allowed address, this I'm going to set it as 0000/0. So for anything. So to the internet, I'm going to go over this tunnel. And I'm just going to hit apply. Now I should actually see that nothing's happening. And why is nothing happening? Well, I haven't allowed the listening port on the AWS security profile yet. So let's quickly do that as well. So I'll just go on to AWS. I'll quickly go into the security for this instance. So I clicked on the instance, go into security, go into my security groups so I can tweak the firewall rules here. I'll edit my inbound rules. And now I will add a rule to allow the WireGuard. So this is going to be custom UDP since WireGuard uses UDP. And then my port is 13231. I'll allow this from anywhere. And I will just call this WireGuard. I'll save the rules. And if I go back onto my client, I can actually see there is some stuff happening and there has been a handshake, which is really good. So quick test, let's see, can I ping 10.0.1.1, which is the WireGuard IP for the CHR on Amazon side or AWS. And hey, I can ping that, and that latency, even though it might look frightening to some people, this is the average latency from South Africa to the US. So this is fine. We go up to Europe and then we go back to the US, which is crazy. But there is the latency. So I actually know that WireGuard is up and running and it's working, but I'm actually not able to do anything yet. It's not actually serving any access to my my home or to the device sitting behind it. So if I go onto this computer or this Ubuntu VM, I can see if I ping out, if I ping 8888, it's pinging, but latency seems extremely low for something that might be in America. And I know exactly why that is. It's because we're not routing any traffic over the WireGuard interface yet. So let's quickly do that. So there's two ways you can go about this. And this all happens from the client now. We're actually technically done from the server. We don't need to tweak anything else there. So from the client, what we can do is, if I look at my routes, you can either use stuff like mangle rules to do routing marks, to mark the packets, so that specific stuff will go out over the WireGuard tunnel. But I'm going to be extremely lazy since I just want all of the traffic always to go over the WireGuard tunnel. I'm going to do the following. I'm going to add a route to the AWS public IP to go out over my normal internet path, because if I just change that default route out, I'm actually going to cause some issues where the tunnel's just not really going to work, because it's going to try and get to the AWS IP over the WireGuard tunnel and it's going to fail. So let's go and just copy this IP and let's route that over my normal gateway. So that is going to go out over 192.168.149.2. I'll hit apply, and then my default route out, so to get to the internet, I'm actually just going to push that out over my WireGuard. So I'm just going to update this default route from this gateway to WG-AWS-US1, which is the WireGuard interface. So it will now push traffic over WireGuard for all internet. Let me hit apply, and that's been done. So next step is, let's go into our terminal. Let's quickly see, can I still ping 10.0.1.1? Yes, I can. Can I ping out to Google's DNS, which is 8.8.8.8? And that is currently timing out. Now, why could that be timing out? Well, I have a theory that the server on AWS's side isn't natting the traffic out. So let's see if I'm right. Sorry, I just thought of that in the heat of the moment. So let's go into the server. And if I look at my firewall rules here, let's just add a NAT rule quickly to say any traffic that goes out of Ether 1, which is my uplink to AWS, I'm just going to masquerade that. Now I actually think everything will work. So if I go back and I run a ping to 8888 again, hey, it works now. So I can actually get to Google's DNS. Perfect. But can I get there from my own home computer? Let's quickly test. I see I've actually got a ping running to 8888, and that is currently failing. Now, why is that failing? Well, same reason. I don't have a NAT rule on this MikroTik to allow that. So you can technically use the allowed from addresses and put your LAN addresses in to allow that access as well. But I'm going to be super lazy and just do this with a NAT rule as well. So we'll do an IP firewall, NAT. And then what I'm going to do is say it's a source NAT. Any traffic that leaves out over the WireGuard interface, I'm going to masquerade that as well. I'll hit apply, and now all traffic will seem like it's coming from 10.0.1.2. So if I run a ping again from this Linux machine, I can see now I am getting a response, which is perfect. So now traffic is going from my client MikroTik in South Africa all the way to my VPN server in the US, and it's working. So technically we've done everything, though there's some stuff that I know that's a bit finicky when it comes to WireGuard and MikroTik, especially when it comes to how browsing feels, because many times people will complain and say the browsing feels really slow even though the VPN is connected. And let's quickly test that and see if we have a similar result. So let's try the browsing out. I'm actually going to open up www.bbc.com, which is a news network and site in the UK, I believe. And we can see it's just kind of like loading. It's not doing anything. So this is indicative to an MTU issue. A lot of people have this type of browsing experience where it feels bad. Like you can still SSH and ping, but you can't actually browse. And what it comes down to is typically the MTU. Now you can tweak stuff with the MTU. I've seen if you actually change the MTU size on the server and the client to 1500, it actually fixes it. It feels fine, but it causes some other issues on the bottom that you can't really pick up and see. So my suggestion is actually keeping your MTU to 1420 on the tunnel, but performing something that we call an MSS clamp for your TCP packets when they perform that initial connectivity. So what we're going to do is just head onto our MikroTik, our client MikroTik. You don't need to do this on the server MikroTik. We're going to head into our mangle rules on our firewall. So IP, firewall, and then mangle. We're going to add a new mangle rule, and the chain is actually going to be forward. Our protocol is going to be TCP. Our out interface is going to be the WireGuard interface. And what else we're going to do is going to our advanced tab. We're going to check the TCP flag. So I'm going to click here and we're going to find the SYN flag. So SYN. And the action, we're going to set this as change MSS. Now you can statically change the MSS value. It's typically, I think, 40 less than your MTU value, but I'm just going to make this, when I click on this drop down, there's a clamp to PMTU, which is kind of like a dynamic way to figure out the clamping. And this typically works fine, but if it doesn't, then just go the static way. So just click on apply, and this is the rule. This is the magic mangle rule that will make the browsing work for your WireGuard tunnel traffic that's running on 1420 MTU. So if I look at this, it's not doing anything yet because it's probably not trying to reach any sites with the SYN package yet. So let's just go back onto our Linux host, and I'll just try and open up www.bbc.com again. And here it's doing its thing. And we can already see there's a massive change. It's actually transferring some data. It's going to the BBC homepage, and there it's opened the website. It's working fine. It's just going to take a little bit of time to load all of these images and such, because I'm connecting on a VPN from South Africa to the US and then back from the US to the UK. So it feels a little bit slower, but it's not because of the tunnel now. This is more or less just a distance thing. But this is what we get. So now we've got the browsing working. So let's quickly just also verify again that I have actually changed my details or where I'm coming from. So if I do a what is my IP and I Google that, we'll see what my current IP address is. And in theory, this should now be showing somewhere in the US. So my public IPv4 address is 54.198.202.70. I'm in Ashburn. Awesome. So we know that works. All right, so perfect. We can verify now that we are actually using the VPN service. And what's nice, it is our VPN. We're managing it. We're Mulvad or Nord or Surfshark. It's us now. We are in control. You know what I mean? So it's actually wonderful. And it's not limited to just VPNs. It's cloud-based networking is really huge. There's so much that you can do with it. But I hope this little taste will at least help you with setting up your own VPN server in the cloud so that you can do those type of cool things without having to pay a VPN provider, because you really don't have to. You can use stuff like this to create your own VPN. Anyways, I'd like to thank you guys for watching. I hope it's been informative. I know it's maybe seems a little bit messy, but I'm doing everything in real time. And I'd also just like to thank everybody that helps support the channel, especially on Patreon and YouTube. I appreciate it so much. And yeah, I'll catch you guys in the next video. Have a good one. Bye.